Hello everyone. In this video, we will discuss about memory management. So one of the memory management scheme is nothing but memory partitioning. So the primary operation of the memory management is to bring all the process into the memory. So that is given for processor for to in order to execute it. So this is what the primary operation. So whenever you bring any of the process into memory, so we need to follow some of the techniques in case of memory management. So we will see first one, memory partitioning. So in this partitioning the memory, so it comes under two categories. So one is nothing but fixed partition and another one is variable partition. So this fixed partition is also considered as a static partition. Variable partition is also considered as the dynamic partition. So here now we will discuss about the fixed partition. So in most of the memory management scheme, the operating system will occupy the first portion of the memory and the remaining portion will be occupied for multiple process. So that is what the section of memory which we have. The memory will be divided into two sections. So one section we use to store the operating system, all the other section we have to store the process, user process. So how we are storing the user process? Either we are allotting the fixed sized memory or we are allotting the variable sized memory. So if you allot some fixed sized memory, then that is nothing but fixed partition. And under that fixed partition, again, it comes under two category. One is equal size partition and another one is unequal size partition. So if you look at the first diagram, this is what given for equal sized partition. So here we have the top section is allotted for operating system and the remaining section has been divided into equal parts or equal partition, and those things will be given for storing the incoming process. So here in the equal partition, we are facing some of the difficulties in this equal partition because so you have the fixed partition here. So whenever any process entering into the memory, right? So whenever any process enters into the memory, so we need to store that particular process into the memory. So what happens there? Um, we have to get the information about what could be the process size. So based on the size of the process, we can allot it. Suppose we can keep only the process which is less than or equal to the fixed partition whatever we have in the memory. So only those process we can allot in the memory. If it exceeds the process, if it exceeds the partition size, then we cannot allot that particular memory. This is one of the difficulty. So what we have to do if the program size or the process size is too big to fit. So that is what the first difficulty we are facing in equal size partition. If the program is too big to fit, what we have to do? The programmer has to follow this overlay concept. So what is this overlay? We have to divide the process or the program into several sections. So one of the section will be stored in the partition whichever available in the main memory. Suppose if you are the other process, other section of the process may be needed by the CPU. In that case, what we have to do? We need to swap the previously stored part of the process and the new part of the process whichever it is needed by the CPU currently. So suppose if the given process has been divided into several modules, so we need to store only the modules that were currently needed by the CPU in the main memory. Because if you don't have some of the partition to hold the entire process, so all the modules which are given for the one process cannot be stored at a time in the given fixed partition. So what we have to do? We have to split the process into several modules, and two of the modules only be stored in the main memory, say for example. And after executing this particular module, and the remaining modules will be swapped into this same space in the memory, and afterwards it will be given for execution. So this is what the concept of overlay. But if you go with the overlay, somewhat it is a time consuming process, because we need to swap in the different modules whatever it is needed for execution, right? So the next one is, suppose if the incoming process size is too small to fit into the fixed partition in the memory. So what happens there? If it is too small, say for example, if you have size of the fixed partition as 8 megabyte, 8 MB, but what your process size is only 2 MB. So what happens here? The remaining 6 MB of space will be wasted. The remaining 6 MB of space will be wasted. So it will not be given for any other process who needs to get into the memory. It is not possible to allot any other process in the same partition. So that is what the another difficulty, and the term what we are calling this kind of issue is said to be internal fragmentation. This is what internal fragmentation. So even if the program is too small to fit, we are facing this difficulty that is said to be internal fragmentation. Even if the program is too big, it is not able to fit into the given fixed partition. So we have to undergo this overlay concept. So the programmer has to follow this overlay concept in order to execute his process. So these are all the difficulties are lessened by using this unequal sized partition. So these are all said to be unequal size. So if you look at this, we have one section of memory will be given to operating system. The other section has been divided unequally. So though it is a fixed partition, but it is not an equal size. See, look at here, the first partition which is size is 2 MB, and the second partition size is 4 MB, and the third partition size is 6 MB. So it may vary with their size of the partition. So it is nothing but unequal size of the partition. It is also fixed partition, but it is in unequal size. So with the help of this unequal size, we can lessen the difficulties whatever we faced in equal sized partition, but we are unable to solve the entire issue whatever we faced there. Okay, so what we can do, we can fit the program whichever is too large, we can get any other partition in order to hold it. And if the program is too small, according to its size, we can allot the particular partition to fit into that process. So this is what we are actually following in case of unequal size. So it is somewhat minimizing the issues of whatever we faced in equal sized partition. So let us see how we are assigning the memory for the fixed partitioning. So here if you look at this diagram, and this comes under unequal sized partition. So here the first diagram will tell us about one process queue per partition. So here we will be having the separate queue will be maintained for loading all the process into the memory. One by one we are actually storing the process into the memory, right? And separately we are just maintaining queue for each and every partition whatever we have. So though it is unequal size partition, so we are actually following the separate queue will be maintained for unequal size partition. And what happens there, the another way, the alternative way of assigning the memory is, we have to follow only one common queue, and in that queue we will be storing all the new process, and whichever the process that were ready or that can be stored into the main memory according to their partition size. Okay, according to the process size, we need to select any one of the partition in order to hold that process. So this is what one common queue we are just following here. So it is also said to be single queue method. So how we are assigning memory for the fixed partitioning? There are two ways to assign the memory. One is we can go with the several queues that were available separately for each and every partition. Otherwise we can go with the single queue concept, and from that queue we can allot the memory for the incoming process. These are all the two ways in order to allot it. So now let's we discuss about the advantages and disadvantages of unequal size partition. So if you look at this, it provides the degree of flexibility, which means we can determine the how many number of process are in ready queue initially. It will maintain the number of process in the queue. So that what we it provides the degree of flexibility. And also the another one is it is too simple and require the minimal OS and processor overhead. So it will not intervene the too much with the operating system or the processor, and it is simple to implement, easy to use. All these are said to be advantages of an equal size partition. So if we go and check with the disadvantages of unequal size partition, which is nothing but we are specifying the size of the partition in generation time itself, which means before allotting the during the architectural design of the OS or the memory design itself, we are just specifying what could be the size of each and every partition. Though it is a variable partition, so we are allotting the size of the partition. It is a predefined thing, we cannot change it. Okay, so according to the fixed partition size only, we can allot the incoming process. Suppose if the process size is too big, then all the fixed partition whatever we have in the memory, we cannot change it. So that particular process may not fit into that size partition. So that is what it is also said to be one of the issue what we faced under equal size partition. So though we are minimizing all those issues, but it is not solved completely, right? So that is what again we are facing that particular issue in this. And here nowadays we are actually almost we are not using this kind of partitions, fixed size partition and also in earlier IBM mainframe as well as the OS MFT, which stands for multi-programming for with a fixed number of tasks. That is what MFT. So all those kinds of operating system were used this technology, that is fixed partition memory management scheme. Okay, so